Subnetting scenario. Empty addressing table. Design an IP addressing scheme. Subnet 192.168.100 prefix 24 network into the appropriate number of subnets. Based on the topology, how many subnets are needed? 1, 2, 3, 4, and 5. 5 subnets. How many bits must be borrowed to support the number of subnets in the topology table? Okay. 2 is the base for the binary system, power 2. 4 subnets, not enough. 2 power 3. 8 subnets, and 8 subnets support the requirement. You need 5 subnets, so 8 covers that requirement. But the answer is 3 borrowed bits. 3. Okay, the original subnet mask is 24. This is 24 in binary, but I will use 3 borrowed bits. 3 borrowed bits supports 8 subnets. Okay, 3 bits. This is 27. How many subnets does this create? 2 power 3, 8 subnets. How many usable hosts does this create per subnet? Remember, this is the network portion, 27 ones, and this is the host portion, 5 zeros. And do the following: 2, the base for binary system, power 5, the number of bits of host portion, minus 2 equal 30 hosts. The answer is 30 hosts. Okay, remember, usable host per subnet supports 30 hosts. And 30 hosts here is a good number to support 25 hosts in each subnet. Calculate binary value for the first 5 subnets. The first 2 subnets have been done for you. Okay, calculate. Remember, the base network address is 192.168.100.24. Okay, 192.168.100.24. Okay, place this here. The first 2 octets in decimal 192.168. The last 2 octets in binary, 100 in binary is 64 plus 32, 96 plus 4, 100. Okay, this is 100, 64 plus 32 plus 4, 100, and 0 in binary here, 8 zeros. Okay, 192.168, 100, 0. Okay, this was 24, the original subnet mask, 24, 8 bits, 16 bits, plus 8 bits, 24 bits. This is the original subnet mask. But I said how many bits must be borrowed to support the number of subnets in the topology table. I said 3 bits and creates 8 subnets, and we'll use 30 hosts per, and we'll have 30 hosts per subnet. Okay. The original is 24, but add 3 bits, 3 borrowed bits. Okay, and copy this. 8 subnets. 2, 3, 4, 5, 6, 7, and 8. Okay, these are the 3 borrowed bits. The first will be 0, 0, 0. In binary, the next number is 0, 0, 1. The next number 0, 1, 0. The next 0, 1, 1. The next number 1, 0, 0. The next 1, 0, 1. The next number 1, 1, 0. And the final number 1, 1, 1. Okay, this is 0 in binary, 1 in binary, 2 in binary, 3 in binary, 4 in binary, 5 in binary, 6 in binary, and 7 in binary. 0, 1, 1, 2, 3, 4, 5, 6, 7. From 0 to 7, 8 subnets, and fill the remaining spaces with zeros. Okay, and the network address is this: 192.168.100, 0. 192.168.100, 0. Subnet mask 27. Okay, 24 plus 3, 27. This is 32. 192.168.100, 32, 27 subnet mask. This is 64. 192.168.100, 64, 27. This is 64 plus 32 is 96. 192, 168, 100, 96, 27. And you will see a pattern here. 0 plus 32 is 32, 32 plus 64 is 64, 64 plus 32 is 96, 96 plus 32 is 128, 128 plus 32, 160, 160 plus 32, 192, 192 plus 32 to 24. When you have a subnet mask or prefix of 27, you need to add 32 for each subnet. Calculate the binary and decimal value of the new subnet mask. The new subnet mask is 27. Okay, go here. For 27, 224, 27, and the binary is this 27 ones and 5 zeros. Fill in the subnet table. So fill this subnet number 01235. Okay, you will fill only from 0 to 7 because they are only 8 subnets. Okay, the maximum number here is 1111. So that's why from 0 to 7 they are 8 subnets from 0 to 7. This is the subnet 0, one, 0, 1, 2, 3, 4, 5, 6, 7. From 0 to 7, 8 subnets. And these are the subnets. Okay, but also use the first usable host IP address, the last usable host IP address, and the broadcast address. There are many ways to do this. One is the following. Copy this here and fill the remaining spaces with ones. And if this is the network, is this is the broadcast here. And this number is 100.31. If this is 32, this is 31. And 168, 131. Same subnet mask. And the first host is one next to the network 1. And the last IP host is one before the broadcast, 30. Okay, also do this on subnet 1. Copy this and fill the remaining spaces with ones. This is the network address, is this, but this is the broadcast. And this number is, if this is 64, this is 63. The broadcast for subnet 1, 192.168.163, subnet mask 27. The first IP is one next to the network, 33, and the last IP is one before the broadcast, 62. Another way to do this is the following. For subnet 2, I want to know the broadcast. Verify subnet 3 network address 96. And the broadcast of subnet 2 is one IP address before the network of subnet 3. So if subnet 3 is 96, the broadcast of subnet 2 is 95. 192.168.195.27. Allow the first IP host 65 and the last IP host 94. Okay, and for subnet 3 broadcast, if this is 128, this will be 127. First IP 97, last IP 126. Okay, here the broadcast of subnet 4 1 IP before the network of subnet 5. If this is 160, this will be 192, 168, 100, 159. Hosts 129, last IP 158. Okay, this will be 191. First IP 161, last IP 190. Okay, subnet 6, this will be 223. First IP 193, 27, last IP 222, 27. And how to know this broadcast? Use the another method. Copy this and fill the remaining spaces with ones. And this number is 255, 8 ones. 192, 168, 100, 255, 27. First IP host, 225, last IP 254. Very good. And this is the table. This table is this. Assign the subnets to the network shown in the topology. Subnet 0 to LAN connected gigabit 00 on R1. Okay. Subnet 0 to gigabit 00 connected on R1. This. Okay. Subnet 1, gigabit 01 on R1. This. Zero one on R1. Subnet 2, gigabit 00 R2. This. Gigabit 00 on R2. Subnet 3, gigabit 01 R2. This. Gigabit 01 on R2. Subnet 4 to the one link between R1 and R2. This. document the addressing scheme. Fill in the addressing table using the following guidelines. Okay, copy this, Control C, paste. First usable IP address in each subnet to R1 for the 2 long links and the 1 links. First IP on this subnet on gigabit 00 on R1. First IP on this subnet on gigabit 01 on this subnet. And first IP on serial 000 on this subnet, the 1 link. Okay, for subnet 0, first IP is this R1, gigabit 01, subnet 1, this. First IP for the 1 link on R1, this is subnet 4, the link between R1 and R2. Use the first. And subnet mask all 27 for all is 255, 255, 255, 224. Okay, in all cases. No default gateways because router is the default gateway. First usable IP addresses in each subnet to R2 for the long links. And aside the last usable IP address for the 1 link. Okay. For R2 on this subnet, the long is for gigabit 00, the first IP for this subnet. For this another subnet, gigabit 01, the first IP. And for serial interface, serial 000, the last IP on this subnet, the link between R1 and R2. For subnet 2, R2 gigabit 00, the first IP, this gigabit 00, this. R2 gigabit 01, the first is this, 87. And for serial 000 is subnet 4, the connection between R1 and R2. Use the last IP, is this, 158. Use the same subnet mask for all cases. Now the default gateway. Assign the second usable IP address in the attached subnets to the switches. Okay. S1 on subnet 0, this subnet, if first is 100.1, use 100.2. For S1, 100.2. For S2 on subnet 1, if first is 100.33, second 100.34. S3 subnet 2 will be 166. Okay, 66. Okay, be careful. S4, subnet 3 will be 98. 98. Same subnet mask for all switches. And for configure the default gateway is the first IP address on each subnet. .1, .33, .65, ID7. Assign the last usable IP addresses to the PCs in each subnet. PC1, subnet 0. Subnet 0, PC1, last IP. PC2, subnet 1, last IP. PC3, subnet 2, 94. PC4, subnet 3, 126. Same subnet mask for all. On the default gateway, the first IP address on each subnet. And is this. Okay, you can verify subnet 0, the first IP, the default gateway 1, subnet 1, 33, the default gateway, subnet 2, 65, subnet 3, 97. 133, 65, 97. Very good. Table complete. Assign IP addresses to network devices and verify connectivity. Most of the IP addressing is already configured on this network. Implement the following steps to complete the addressing configuration. EIGRP dynamic routing is already configured between R1 and R2. Configure R1 LAN interfaces. Configure both LAN interfaces with the addresses from the addressing table. Okay, on R1, go to R1, command line interface, enter, enable configure terminal. Use the addressing table. Only LAN interfaces. Only LAN interfaces. I guess serial interface was previously configured. Okay. Interface gigabit 00, IP address 192.168.101, net mask 224, not shut down, and gigabit 01, IP address 133, subnet mask 224, not shut down. Configure interfaces so that the hosts on the LANs have connectivity to the default gateway. Okay, no problem with this. This is already configured. This entry means configure the LAN interfaces. Configure IP addressing on S3. Okay, go to S3, command line interface, enter, enable, configure terminal. VLAN 1 interface with addressing. Okay, go to addressing table, configure this, interface VLAN 1, interface VLAN 1, IP address 192.168.166, net mask 224, no shutdown. Okay, don't forget the default gateway exit IP default gateway 192.168.165. Okay, default gateway. Okay, this already configured. PC4. Desktop IP configuration. Addressing table. Configure all this. 192.168.100.26. Subnet mask 224. Default gateway 192.168.197. Verify connectivity. You should be able to ping every IP address listed in the addressing table. PC4 and command prompt. Addressing table. Ping PC1 192.168.130. Success. PC2 62. Very good. PC3 94. Very good. Switch 1 S1 102. Success. Repeat. Very good. Switch to S2 34. Success. Repeat. Very good. S3 66. Repeat. Very good. S4 98. Very good. 100%. Thank you very much.